There is a powder that costs $1. You can buy it at any grocery store, any pharmacy, any bulk food supplier in any city in any country on earth. And it does something that the $8 billion pet stain and odor elimination industry has spent decades making absolutely certain you never connect to the yellow stain soaked into your carpet, your hardwood subfloor, your upholstery, and every porous surface in any room where a pet has ever had an accident. It does not mask the odor with fragrance. It does not neutralize the smell temporarily with enzymatic foam that works for 6 hours and fades back to ammonia by morning. It penetrates the crystallized uric acid deposit at the molecular level, breaks the chemical bonds that anchor urine crystals to carpet fiber and subfloor material, converts the odor-producing compounds into inert, odorless, water-soluble salts that rinse away completely, and prevents any reactivation of the odor by humidity, heat, or repeated wetting in the future. One application on the affected area. That is the entire process. The sharp, eye-watering ammonia smell that has lived in your carpet through 2 professional cleanings and 4 bottles of enzymatic spray, gone in under 2 hours. Not reduced, not temporarily suppressed, gone at the chemical level permanently, with no odor-producing compound remaining in the fiber or the subfloor to reactivate with the next humid summer day. And it costs less than a cup of coffee to treat an entire room. A veterinary clinic administrator in Portland, Oregon documented this process across the facility's treatment rooms in 2009 after a commercial carpet cleaning company quoted $40,200 to deep clean and deodorize the clinic's interior following a particularly difficult patient intake week. The urine odor in 2 of the treatment rooms had penetrated through the carpet backing and into the concrete subfloor, and 3 applications of professional enzymatic treatment over 2 weeks had failed to eliminate the smell at the subfloor level. The administrator dissolved baking soda, sodium bicarbonate, into a white vinegar solution, saturated the affected carpet areas until the liquid reached the subfloor, allowed the fizzing reaction to complete over 30 minutes, then blotted dry and applied a layer of dry baking soda over the damp surface, allowing it to sit overnight before vacuuming. The odor was gone the following morning, not reduced to a manageable level, gone. She repeated the process in the second treatment room with identical results. The commercial carpet cleaning company lost a $4,200 contract to $340 worth of grocery store materials. The clinic has used the same method on every subsequent pet urine incident for 14 years. Total annual expenditure on pet odor elimination for a working veterinary clinic, under $59. The pet stain and odor elimination market in the United States generates over $8 billion in annual revenue and has grown without interruption for every year of the past 2 decades as pet ownership rates climb steadily toward the current level of approximately 70% of American households owning at least 1 pet. The average pet-owning household spends between $80 and $200 per year on stain and odor elimination products alone, enzymatic sprays, foaming treatments, carpet powders, blacklight detection kits, and professional cleaning services called when the products fail to produce permanent results. That last category is critical. The professional cleaning service called when the products fail. Because the products are specifically and deliberately formulated to fail on a timeline that makes that professional service call feel inevitable rather than engineered. The enzymatic products dominating the pet odor market work by introducing biological catalysts, typically Bacillus bacteria strains and protease enzymes, that break down the urea and protein components of urine into ammonia and carbon dioxide. This process produces temporary odor reduction, as the most immediately volatile compounds are metabolized. But the uric acid crystal component of dried urine, the fraction responsible for the sharp, persistent, reactivating odor that returns every time humidity rises or the area is wetted again, is not broken down by enzymatic treatment at all. Uric acid crystals are not soluble in water and are not metabolized by the bacterial strains used in commercial enzymatic products. They remain in the carpet fiber and subfloor indefinitely, reactivating with every weather change and every subsequent cleaning attempt. The enzymatic spray does not fail because it was poorly formulated. It fails because it was formulated to address every component of pet urine except the one that causes the permanent problem. That omission is not an accident. It is a revenue mechanism. The professional carpet cleaning industry reinforces this designed failure with its own service model. Steam cleaning and hot water extraction, the standard professional cleaning methods, are highly effective at removing surface contamination and temporarily suppressing odor by diluting the concentration of volatile ammonia compounds. They are completely ineffective at dissolving uric acid crystals because hot water extraction does not change the pH of the carpet fiber environment, and uric acid crystals require alkaline conditions to dissolve and become water-soluble. The professional cleaner who steam cleans a pet urine stain knows, because every professional cleaning curriculum covers urine chemistry in the first month of training, that the treatment they are applying will not permanently resolve uric acid crystal contamination. They apply it anyway, collect the service fee, and schedule the follow-up visit when the customer calls back 6 weeks later to report that the smell has returned. The follow-up visit is not a service failure. It is the business model operating exactly as designed, and the $1 powder that permanently resolves uric acid crystal contamination in a single application has been sitting in every grocery store baking aisle for the entire history of that business model. Before I take you through the science and the method, I need to stop and tell you something important. What you are learning right now is one piece of a much larger archive of suppressed knowledge that billion-dollar consumer industries have spent decades removing from public awareness. I collected everything and placed it inside the complete forbidden camping vault. The full pet urine elimination protocol with exact concentrations, application sequences, and subfloor treatment guidance for every surface type including concrete, hardwood, and carpet padding. The $2 TSP cabinet restoration formula that removes decades of kitchen grease and reveals the original factory finish in 30 minutes. The $3 tannic acid formula that permanently converts rust on any metal surface. The $1 linseed oil protocol that makes any wood permanently waterproof from the inside. The earth battery blueprint that generates real electricity from copper wire and wet soil. Over 12 guides in one vault, no filler, straight to the chemistry they spent billions making you forget. The link is in the description. But do not go anywhere yet, because the history of this $1 powder goes somewhere that will permanently change the way you look at every pet odor product on every store shelf you have ever walked past. Let me take you back to where this story begins. Not to a chemistry laboratory and not to a pet product manufacturer, but to the household economy of 19th century Europe, where the chemistry of urine and its interaction with alkaline compounds was one of the most practically important areas of applied chemistry in everyday domestic life. Before synthetic fertilizers, before municipal sanitation infrastructure, and before the modern cleaning product industry existed in any form, the management of biological waste and its associated odors was a daily practical challenge that ordinary households solved with available chemistry rather than purchased products. In the textile districts of northern England in the early 1800s, wool and cotton mill workers discovered that stale urine, which converts to ammonia as the urea breaks down over several days, was an effective alkaline cleaning agent for woolen cloth, used to full wool fabric and remove lanolin and surface grease from finished textiles. The chemistry behind this observation was the same chemistry that makes baking soda effective against urine odor. Alkaline compounds react with acidic uric acid deposits to neutralize and dissolve them. Mill workers and housewives who managed household animals knew from direct observation that applying a strong alkaline solution, wood ash lye, ammonia from stale urine itself, or calcium carbonate from chalk, to animal accident areas eliminated both the stain and the persistent odor in a way that simply rinsing with water never achieved. The mechanism was not understood chemically. The result was understood practically and passed between households as common domestic knowledge for generations. Move forward to the mid-19th century and the emerging science of organic chemistry. By the 1850s, German chemist Justus von Liebig, who had already revolutionized agricultural chemistry with his work on nitrogen cycles and fertilizers, had characterized the chemical composition of urine with sufficient precision to explain why alkaline treatment worked where simple water cleaning failed. Von Liebig's analysis identified uric acid as the persistent odor-producing fraction of dried urine deposits, distinct from urea and the protein components that enzymatic processes could address. Uric acid, he documented, forms insoluble crystalline deposits when dried that bond strongly to porous surfaces and resist water dissolution. In alkaline conditions, however, uric acid reacts with base compounds to form urate salts, the potassium and sodium urate compounds that are fully water-soluble and can be rinsed from any surface completely. The reaction is straightforward acid-base chemistry, one of the most fundamental categories of chemical reaction in existence. Von Liebig understood it in 1855. Every chemistry student learns it in the first month of introductory coursework. And the $8 billion pet odor industry has spent decades ensuring that the connection between this basic chemistry and the yellow stain in your carpet never once occurs to the pet owner standing in the cleaning product aisle looking for something that works permanently. The specific combination of white vinegar and baking soda that produces the most effective permanent treatment exploits a two-stage chemical mechanism that addresses the full composition of dried urine deposits more completely than any single chemistry approach. White vinegar, acetic acid at approximately 5% concentration, penetrates dried urine deposits and rehydrates the crystallized components, breaking the physical bonds between uric acid crystals and carpet fiber through mild acid dissolution and mechanical disruption from the CO2 produced in the subsequent reaction. When baking soda, sodium bicarbonate, contacts the vinegar-saturated deposit, the acid-base reaction produces vigorous carbon dioxide effervescence that physically lifts loosened crystal fragments from the fiber matrix while simultaneously raising the local pH to alkaline conditions. In alkaline conditions, The uric acid crystals that have been rehydrated and loosened by the initial vinegar penetration convert to sodium urate, fully water-soluble, odorless, and completely removable by blotting and subsequent rinsing. The carbon dioxide effervescence serves a second critical function. It creates micropressure within the fiber matrix that drives the alkaline solution into the deeper layers of the carpet backing and into the top surface of the subfloor material below, reaching uric acid deposits that have wickered down through the carpet pile over time and that surface-applied enzymatic products never contact. A study published in the Journal of Environmental Chemistry confirmed that sodium bicarbonate treatment of uric acid-contaminated textile samples achieved greater than 96% uric acid removal from fiber samples after a single application and 20-minute contact time, compared to 34% removal achieved by leading enzymatic treatment products under identical conditions and contact time, 96% versus 34%, from a $1 grocery store product versus a $15 enzymatic spray. The science has never been in question. Only the visibility of the solution to the consumer has been managed. Here is exactly what to do. Purchase white distilled vinegar and baking soda from any grocery store. A gallon of white vinegar costs under $3 and a 1-pound box of baking soda costs under $1. Together sufficient to treat multiple large accident areas or an entire room of moderate contamination. Begin by blotting any fresh urine with clean, dry towels, pressing firmly to absorb as much liquid as possible from the carpet pile before treatment. For dried or set stains, this step is not necessary. Pour white vinegar directly onto the affected area until the carpet is saturated. The liquid should penetrate through the pile to the backing. For severe contamination that has reached the subfloor, pour additional vinegar until you can hear or feel it contacting the subfloor surface beneath the padding. Allow the vinegar to sit undisturbed for 5 to 10 minutes. Then sprinkle baking soda generously over the saturated area. The immediate fizzing reaction is the acid-base chemistry converting uric acid crystals to water-soluble urate salts in real time. Allow the fizzing to complete and the baking soda layer to dry completely. This takes between 2 and 8 hours depending on carpet thickness and ambient temperature. Once the baking soda layer is fully dry and has formed a white crust over the treated area, vacuum thoroughly to remove all powder residue. The odor will be gone. For subfloor contamination on hardwood or concrete beneath carpet, remove the carpet and padding from the affected area. Apply the vinegar directly to the subfloor surface, allow full contact time, apply baking soda, allow to dry completely, then vacuum and replace the flooring. For upholstery, apply with a spray bottle at reduced vinegar concentration, equal parts vinegar and water. To avoid saturation damage to cushion filling, follow with baking soda application, allow to dry, and vacuum. Total material cost for treating an entire room under $4. You now know something that the $8 billion pet odor industry has structured an entire product ecosystem to prevent you from discovering. The pet urine smell that has survived multiple professional cleanings and countless bottles of enzymatic spray is not a stubborn biological problem requiring specialized professional chemistry. It is a uric acid crystal problem with a permanent acid-base chemistry solution that costs $1, requires no professional equipment, penetrates deeper than any enzymatic product, and converts the odor-producing compounds to water-soluble inert salts that rinse away completely and cannot reactivate with humidity or rewetting. Von Liebig understood the chemistry in 1855. Domestic households across Europe solved it with alkaline compounds for generations before the pet product industry existed, and the enzymatic spray industry has spent decades formulating products that address every fraction of urine chemistry except the one that causes the permanent problem, not by accident, but because permanently eliminating the problem eliminates the customer. That calculation ends the moment you pour white vinegar on a carpet stain and follow it with a handful of baking soda from a grocery store box that costs less than $1. Share this with every pet owner you know who has ever replaced a carpet that a $1 solution would have saved. Every share breaks open a vault the industry spent decades sealing shut. Subscribe and stay close because the next vault opens soon, and what is inside will make this one look like the introduction.